Welcome back to lab. Today we're going to be talking about t-tests. Specifically, we're going to be doing another statistics review focusing on t-tests. We kind of touched on these in lab 4 of our course, but we're going to just be going over it again because it's always helpful. Then we're going to go over again how to run t-tests in SPSS, as well as how to generate bar charts in SPSS. Most of this will feel like a review from lab 4, but if you didn't understand it then, this is your chance to ask questions. This is the last time we're going to address t-tests before it is all going to be due for your results section. You're going to have an assignment that has to deal with creating the output for your particular paper. So if you have any issues with it, now is the time to reach out to us. But as a review, we have two types of analyses that you could do in your study. We had the correlation with two continuous variables. We talked a lot about that last lab and how to display a scatter plot with a regression line. But the other opportunity that you might have is a t-test. This is when there is a single continuous dependent variable and a categorical independent variable with two groups. If you have more than two groups, you need to use an ANOVA, but we are not covering that. If you haven't already reached out to your TA to talk about an ANOVA, do it now. We're going to compare the means of the groups, and we're going to tell if the difference between those means is statistically significant, and we're going to display this with a bar graph. As a review of a t-test, this is used to determine if two groups are significantly different from each other on the same dependent variable measure. In an independent samples t-test, you are comparing two separate groups who have undergone different experiences. This is, as you just learned in the lecture video, a between subjects design, because each participant is only experiencing one level of your IV. You might remember that I called a between subjects group an independent samples design as well, independent subjects design. That is the same reason that it's called an independent samples t-test, because the participants in one group are completely independent from the participants in the other. However, a paired or a dependent t-test is when you're comparing the repeated measures of two time points. So this is a within subjects design where the same participants are taking the measure once and then later taking it again. We are not doing that in our study. We're not doing a paired samples t-test, but there you see there is a within subjects version of between of the independent samples, of a t-test, I should say. But we're going to use the between subjects version for the data that we collected. When you are doing a t-test, you are checking to see if the differences in the study are due to chance, that you're finding some difference between the means of your blue group and your orange group, and you're testing against the null or the alternative hypothesis, that HO or the H1. The null hypothesis in any study is that any differences in the DV scores are just due to random error. There is no real effect in the real world. But if we're able to find that the likelihood of that being true is very small, then we're left with the alternative hypothesis, which is that the difference you found is something that's actually happening in the real world as a cause due to your IV. So the differences in the DV scores are due to the IV. So we're always going to see some overlap between groups. There's always going to be some difference. There's always something. There's never exact. There's variance. There's people are different. But is the group difference there big enough for us to say that there's actually an effect there? So you're looking at one has a very big difference between them. So we're seeing if generally people in blue group versus orange groups have generally different scores versus our second picture. We see kind of a lot of overlap between the blue and the red group. That looks like participants are kind of saying, yeah, there's a difference in scores, but it's pretty close. So that probably wouldn't pass statistical significance. We want to see a big enough gap that the spread of the data doesn't overlap very much. That's like the essential purpose of an independent samples t-test, is to see, does the spread of the data not overlap that much? It only overlaps a little bit. To follow along today, please choose a continuous variable from the available data set. We've talked about the continuous variables at some length by now, as well as a demographic variable with only two categories. Those are the dichotomous variables. I have those listed in the top corner there, the ones that are available to you. Reminder that some of the variables, the original variables, have multiple levels, but I did talk about in a previous lab how they were converted into dichotomous levels, so there's only two options, two categories, instead of more than two when you wouldn't be able to run a t-test. Then, if you have any questions, you can use the demographics and scale information document that is on Canvas. Now today, what I'm going to be doing is using the question, do men and women differ on stress levels? So for that, I'm going to use the continuous variable of stress levels and the demographic dichotomous variable of gender, which is male-female. My null hypothesis for this question is that stress levels are not different depending on gender. There is no difference there. Whereas my alternative hypothesis is that stress levels are different depending on gender. Okay, so you see, if there is not no effect, then there must be an effect. Logic. So to run a t-test in SPSS, you're always going to go to Analyze, and you're going to look at that Compare Means and Proportions, and you're going to see the third drop-down is Independent Samples t-test. There are other t-test options as well as an ANOVA option. You're not going to use any of those, obviously. We're just using the independent samples, but that's where you would find the other ones. We're doing under Compare Means because that's essentially what we're doing. We're comparing the means of those conditions. I'm then going to move the continuous variable that I'm using or that you're using into the test variable column. That is always your continuous one, and that is for us going to be college stress average. And then you move your categorical variable to the grouping variable. For me, it is male, female. And as you might recall, there's going to be those two question marks in parentheses because you haven't defined the levels that you are looking at. What are the actual condition values that SPSS has to interpret? Because you could be using a variable that has more than two levels, but a t-test is only able to look at two of them at a time. So we have to go ahead and define those groups. You do this by first figuring out what the different value labels are. And you can find that on the value labels on the variable view tab. If you're confused about that, go back to lab 4 and it shows you that kind of step-by-step of how to check the value labels. But if you are still in the t-test, you click the define groups and you enter the values. So for the male-female, I have that female equals 1 and male equals 2. There is an other value that is a byproduct, but we're not going to use that one at all. So we're going to put in female and male, and then make sure that group 1 and 2 are targeted. You could put it in any order of group 1 is 2 for male and group 2 is 1 for female. The order does not matter. You just have to remember what order you put them in, and then you can click continue and then OK. From there, it's going to give you a t-test output in your output window. Reminder that if you can't find it, it's probably just hidden somewhere. It sometimes pops open and doesn't tell you where. This is going to have a number of different pieces of information on it. Specifically, the group statistics, which are the mean and standard deviation of your two independent levels groups. So how did females do on stress? How did they score on stress? And what was the spread of their data on stress? Not all of them are scoring a 3.1978, but that's just the average, and then there's a certain amount of deviation from there. And the same thing for male, who have a 3.1675, and they have their own spread. What a t-test is trying to do is figure out, is there a lot of overlap in those spreads? Is the difference between those means actually a difference? Or are they pretty much the same spread of data? They just have a slightly different center point, right? Is the spread, the standard deviation of my two samples pretty similar? So to figure out if that difference between the 3.1978 and the 3.1675, that is the difference between male and female scores on college stress, is that different? We look at the independent samples test. Here we see the mean difference between my group A and group B, or male and female in this situation, which is just a 0.03. But we don't know if 0.03 is big or small. We have no context for that. We just know that there is a difference. It might look small to us right now, but is it? I don't know. Let's do an analysis. So that's where we get our t-test. This is the magnitude of the difference between the group. How much does that difference matter when taking into account the standard deviation and the amount of spread that's happening? If both groups have a very little amount of spread, they're very tight distributions of data, well then it's going to be harder to find overlap and differences might be more salient. But if there's a lot of spread, a big standard deviation, and there's a lot of overlap, that magnitude is going to be a lot smaller. You're also always going to compare it to your degrees of freedom, which is the number of participants whose data was used, minus 1 for each condition. A independent samples t-test always has 2 conditions, so it's going to be your total participants minus 2. In this case, it's 74 females plus 13 males is 87 participants, and then you subtract 2 from that for the 2 groups, and you get an 85 degrees of freedom. And then you test to see whether that is significant. What is the likelihood that you found that mean difference of 0.03 when there is no effect in the real world? And what it's telling you here, you're always looking at a 0.05, and this is telling you, is it not significant? No, that's nowhere near a 0.05. A 0.45 is way bigger. So there is no significant difference between males and females on stress based on this analysis. Now you'll see with the significance that there are 2 options. There's a one-sided versus a two-sided. So you might have had questions about which one do I use? When using a one-sided or a one-tailed versus a two-tailed, the difference is whether you have a directional hypothesis. In a one-tailed significance or a one-tailed test, you only use this if you have a specific directional hypothesis. That is, if you think one group is going to score higher or lower than the other. You expect it. You have an idea, you have a theory that one group is going to perform differently on your IV in a certain way. So in our case, it might be we have a hypothesis that females will have higher stress than males. Or I could say females will have lower stress than males. I have to have chosen before I run the statistical test. So if you are writing up your paper and you have a very clear idea that you think one group is going to perform, is going to have a higher score on your dependent variable than the other, you can go ahead and use the one-tailed significance. And the perk to a one-tailed significance is that it's in fact easier to reject the null hypothesis, but that's only if the direction actually happens in the way you think. So if I had a hypothesis that females will have higher stress than males, and then I ran an analysis and I found that actually males have a higher stress level than females, so the opposite, I would have to fail to reject my null hypothesis. I would fail to find support for my hypothesis because my hypothesis was in the exact wrong way. I had the exact opposite hypothesis to what the data actually said. So you got to be careful there. If you have a really good reason to believe in your hypothesis in one direction or the other, go ahead and use that one-tailed. But if you don't have a specific direction, that's when you should use a two-tailed test, and this is the most common. This is when you think that there is a difference, that the IV is having some effect on the DV, but you don't really know how it's going to affect it. So this example might be females and males will have different levels of stress. I don't know if one's going to be higher than the other. I just think they're going to be different. And it could be one way, could be the other. I don't know. I just think they're going to be different. This is technically harder to reject the null hypothesis because of the way p-values work, but it does accept either direction of relationship, so you get a little bit more flexibility if you're not really sure how the relationship should go. So when you're reporting a t-test, you should always be looking for the group statistics as well as the degrees of freedom, which are in the parentheses, the significance level, and the observed t-statistic. And you can find all of these. There's a table here that says where to find them. The group statistics are in the group statistics table. And then I've already pointed out where the degrees of freedom, the p-value or significance level, and the observed t-test statistic. Those are the data you need. And then when you put them in APA style, you need to start by describing what test was looked for and what test you ran and why, and then you need to include all of those pieces of information. So as an example, I would write, an independent samples t-test was conducted to determine whether there is a difference in college stress as a result of gender. You see how I've clearly described my independent variable and my dependent variable there. I then tell you how did the different groups perform. So the mean score of stress for female students, there it is, M equals 3.20, standard deviation equals 0.82, was not significantly higher, very important, they're not significantly higher than the stress scores for male students, M equals 3.17, SD equals 0.69. I then report the T with the degrees freedom of 85 in parentheses, and then it equals 0.126 with the p-value of 0.90. And this matches the exact data that we saw on the output. I have all of the group statistics. I have the degrees of freedom, the significance level, and the T statistic in that answer. And that's it. The next step that you're going to have to do is to graph your t-test, to show off the differences visually. And this is going to be a bar chart, which clearly compares the differences between the groups. Specifically, how do the means from one group compare to the average mean for the average scores for the other, the mean for the other group. For this, you're going to go under Graphs and select Bar there. You're creating a bar chart or a bar graph maybe, and you're going to do Graphs Bar. When you click that, it's going to pop open with this window that has a couple of different options for types of bar charts. We're just going to use a simple bar chart for this. And you want to make sure that it's summaries of groups of cases. So individuals are going to be in groups, so you want to group their data based on which level of IV they're at. And then you click Define. This will take you to a big window, and under bars represented, the first thing you need to do is click Other Statistic, for example, mean there. It's currently selected at N of cases, which is the number of cases, which you don't really need. We're looking for the means that we're going to track. And once you click that Other Statistic Mean radial button, it's going to ungray the variable option, which allows you to move that over. Here you're going to move over your continuous dependent variable to that variable cell. Once it's in there, you want to go to Change Statistic, that button right underneath the variable, and ensure that mean of values is the selected statistic, and then you can click OK or Continue. There's lots of different other statistics you can include instead of the mean, but we are going to do the mean. Once you're back on the Define Simple Bar Chart window, you then select your categorical IV and move it over to the category axis. This is where it'll label the different bars for the different groups so that you can see how their means compare. You can then click OK. So this is the visualization that I get when I click that button. You can see here it has along the x-axis the female-male SPSS variable, and the y-axis has the mean college stress average, which is the mean of the college stress variable. And then the two bars indicate the female and male scores. You can clearly see here a visualization that there is not much difference between female and males in terms of college stress. So it is a good visualization of what we can also see in our T statistic, where it was a non-significant finding. However, SPSS variable names are not always very intuitive. Sometimes they can be confusing, and bright blue is not APA allowed. We want to have just black and white. We also want to have some Times New Roman. So what we have to do is go in through SPSS and edit our visualization. You can do this by double-clicking the graph, and it will open a new window, and in that you can edit the colors, the text, etc. So you're going to want to do things like edit the axis title. You can do this by clicking on the axis title once to select it, and then clicking it a second time to edit it. So I would change it to gender. And then you can change the mean college stress average again by clicking it once and then clicking it a second. Important to note, it's not a double click. It is a click once to select and then click a second time to edit and change it to average college stress. You also want to go in and format the colors, which you can double click on the bars themselves. This time it is a double click, and it'll pop up with a window of the properties, and you can tell it what kind of color to use. And so after all of it, I ended up with this. I also adjusted the width of the bars, though you don't necessarily have to do that. I removed the grid lines, which is usually done. You can figure out if you want to. The way I did it was I made the grid lines transparent. And then you want to copy this into Word, a Word document, and give it a figure caption. So I know that was a lot. I don't have the technology for having you screen grab my process as I'm going through this. This is a great thing to ask your TAs, or I have posted a video on Canvas that gives a pretty good introduction to how to, and a pretty good demonstration of how to go about editing a graph in SPSS. I'll also include one of those for scatter plots so that you can get a better idea of how to graph those as well. And when you're done, here's an example of an APA style chart. You can see it is all in black and white. Now this person didn't use Times New Roman. They're using a different font. We want to use Times New Roman. But they have their different groups, and you can clearly see how the different levels of the independent variable of condition are different for education, exposure, and control. And you can clearly see the dependent variable is the clinician rating of severity. Now, what those actually mean, you have to read the paper. But you could also glance down at the figure label at the bottom, which tells you an interpretation, a quick interpretation of the visualization. So this is the mean clinician's ratings of phobia severity for participants receiving the education treatment and the exposure treatment. And then it tells you what those little bars are. Those are your error bars that represent the standard errors. You do not have to include standard errors in your visualization. This is just something that this researcher chose to do, but you can kind of see the general look and feel of a bar graph through this visualization. All right, so that's it for today. It's just the t-test. A reminder that your lab assignment is going to be due Monday. That is the data one. You are pulling your correlations and your t-test. You have to create a scatter plot or a bar chart. You have to make sure you have all the methodology descriptive statistics. I gave you a few weeks ago a little handout so you could know what you needed to pull for your methodology. This time you're actually submitting it for a grade. All of the data that you are submitting through this Lab 5 assignment will be used in your final paper. We are not having you turn in a full methods or results section, but this is the same data that you need to use, so you want to get it right. So next week we're going to be talking more about the results section, how to put it together, and then we're going to move on to discussion, and then you're pretty much just writing a paper. That's all, folks. Bye.